What's up, everyone? What's going on? It's quite a pumping tune to begin with, eh? Far out. Man. Put your hands in the air if you're glad it's Friday. Whew. What a week. And this streaming lark is tiring, let me tell you. I do enjoy it though. Yeah, amen to that. So, yeah, it's been a pretty big week on a number of fronts, and you know, this trying to keep up the streaming every 2 days is certainly taxing. But you know, it's part of the day that I enjoy, so I'm not looking for sympathy or anything. But what I'm going to start with today is a couple of shout outs actually to people, and the first shout out is to my partner in crime, Sean. Goes by the Twitter handle of OzJock. He's the dude's awesome. Being able to work with a guy like that is fantastic, and he consistently goes above and beyond and fights the fight on all fronts, and he's just a fabulous dude to have around. So I'm pretty sure that he won't be on stream now, and he better not be, because he should be hanging with his missus. But I love that guy, and I'm stoked that he's part of my show. You know, couldn't imagine sort of carrying on the work that I do without a guy like that. And you know, he's a top lad. So if you don't know who he is, you should go and hunt him down. He's a good bloke. So cheers to you, Sean. I hate you and your face. Another shout out that I'm going to sing out is to someone who I'm not going to mention, but is a very dear friend as well, and he's had it rough for a little while, and you know, today was a very big day for him. And hey, Peleus, and Mongo and Archbishop and Gombos, thanks for coming in. But yeah, this mate of mine, he's been battling a fair bit of late, and today was a big day, as I said. So I'm not going to say any more. All I'm going to do is say cheers to you and everything that you do. I'm not going to tell you what's in this glass, because it's none of your damn business, but cheers. Oh. That's not tea. But this is. Tonight's brew is called Morning Red. And despite the name, it is actually a black tea. But it's kind of got an interesting flavour that sort of gives you a bit of a kick in the morning. That's right, Archbishop. Very special tea. So Zookeeper, thanks for coming in, mate. So yeah, this is tonight's brew, and it's going to give me the kick I need to maintain myself for the next 90 to 120 minutes. I'm probably going to aim for somewhere around 90 minutes, maybe just a little bit longer tonight, because I'm feeling the burn, but I still want to represent. So thanks for joining in. Hey Eric, you came to me doing some hat tips and whatnot. A Meterer, good evening to you and to everyone else who's joining in. So it's probably worth at this point, you know, sitting back and thinking about the people who mean something to you and giving them a little hat tip. They're all fighting fights that we're probably not even aware of, you know. So be there for your mates. Be there for your mates. It's important. And you know, I'm here if anyone else wants to talk, even if you don't know me that well. Reach out. Happy to listen, happy to lend an ear, happy to share a brew with you over a hangout. But yeah, just, you know, look after your mates. Look after your mates. Okay, on that sentiment, you know, I will pick up the vibe a little bit, but you know, it's nice to be human. My God, that was good. I'm tempted to get another one, but I'm not going to. Right, righto. Probably make me a bit too jolly. So, what are we doing? I'm going to flick the magic VMware button, so hopefully you can see that on screen. Now, hopefully you guys have had the chance to catch up on where we got to last time. If anyone's got any questions about what we did, or you know why we did certain things, even if they're C# noob questions, etc., then fire them in chat. We will answer them along the way. But today's plan is to go over, well, not actually go over what we've done, but rejig a couple of small bits and pieces to allow us to support serialization of the packets that we're currently able to deserialize from, you know, a byte stream. So we're going to do the opposite to what we did on the previous stream. And in doing so, we should be able to sort of test and validate our approach in both directions. Depending on time, I'd like to sort of bake this stuff into a very simple set of unit tests. They're not going to be the ideal unit tests, but they'll be better than nothing. And after that, depending on time, we may sort of just quickly wire in the .NET 4 version of whatever it is that we've got to. So we'll keep an eye on the time and we'll do our best. So thanks again for coming along, everyone. I do appreciate your company, even though for the most part all I ever hear is my own voice. So maybe what I should do is sort of over the course of maybe the next couple of months, I'll get some of you people who consistently appear on stream to sit on Discord or a Hangout or something with me so that I can have some real-time banter / back and forth with somebody. So maybe we can do that, depending on what you guys want to see. Maybe that would be boring. I hope you all have a cup of tea with you, because as we know, hacking / coding without tea is very uncivilized. And we don't want to be uncivilized now, do we? Now, I had some commentary from based off the last stream, that the pace of the last one was significantly better, and I'm glad you agree, because I felt that was the case as well. The previous one we kind of churned and didn't really get very far very quickly, and I think everyone involved in that may well have found that a little bit tedious and frustrating. So this time around, I'm going to continue, or at least try to continue doing what I was doing that time, and with a bit of luck, we'll end up with some code at the end, which is useful to test and serialize stuff. So we're at a point where we can construct ADTs from serialized packets and serialized packets from ADTs, so that at the very least, when we get to the point where we're talking with Metasploit, we can talk packet language. That's at least the plan. Okay. Right. So with that in mind, let's have a look. I keep getting these carriage return line feed warnings, and they're bloody annoying, but it is what it is, right? So, what I think we should do to begin with is arguably, some people might actually look at this as a bit of TDD, and it's not really, because I'm literally going to be implementing one single function, and I may as well sort of just do that up front and have things break in the TDD sense. But do not consider this in any way really any TDD. It's just me fudging some code together and going from the top down rather than the bottom up. Okay, so, but what I'd like to do is pick an example of a packet that is actually constructed in Meterpreter right now, and from there do exactly the same as what we would do, but manually. Okay, so it's TDD for people ashamed to be doing TDD. Let's go with that. Not that I'm ashamed, I just don't find it particularly useful for me for the most part. But let's go with that. Let's run with that, Peleus. And that's the closest thing you're going to get to me saying, Peleus, you are correct during this stream, just so you know. All right, so let's go to GitHub. GitHub.com. Did I type 2 H's there? I did, didn't I? GitHub.com, Rapid7, Metasploit payloads, and let's just make this a little bigger so everyone can see. So what we'll do is we'll go into the C version of Meterp, because I think this would be interesting for you folks to see regardless. We're going to go into metserve. And in Metserve, there's a bunch of code that's interesting. And we will have a look at something like, let's see. No, that's not the one we want. Metserve, liblover, server pivot. I'm trying to find something that would be a really nice example. Server setup win. Let's look at this. There'll be TLV packets in here somewhere, surely. No? What are we looking for? Something that you can actually do as part of core with generation of some kind of response, and it could be something as simple as like channel creation, but I don't know where that is. Let's go back in here. Oh, it's probably in common. That's probably where it is. Let me just go back to source, common. Here we go. Packet encryption, packet dispatch. That's right, it's in common. So somewhere in here, let's look at channel. Here we go. So inside here somewhere, we'll be able. There's code that actually creates channels and then generates TLVs and various other things. So let's just see what TLV we create. Because all I want to do is kind of simulate something that would represent a realistic packet that would actually get sent back. Okay, so maybe if we go packet create, let's see what we got here. There we go. Alright, so create that, completion routine. Okay, that's not particularly interesting. I want something that we could kind of loop through. That's just a uint, that's just a uint. It's got a method. Well, let's just make it up. Bugger it, let's just make it up. We'll go along the lines of this. So, assuming that we're effectively creating let's say we're going to create a request. A response from a request. All right. So let's go with this. Var packet, I should say request equals new packet data 0. So we're going to deserialize the first one. Now what I want to be able to do is go response equals request.create response. So what I want create response to do is to create an instance of a packet, but automatically wire in things like the request ID and the method, because we need to make sure that those things end up going back, but have the correct packet types. Okay. And then when we do that, we want to be able to go and create individual TLVs. Now I'm just going to pick some stuff at random and I'm going to make them groups and things like that just to see if the code actually behaves as we expect. And then I'm going to serialize it. And what I'm going to do after that is deserialize it again, just using the same code to see if the serialization and deserialization is actually doing exactly what we would expect it to do. Okay? So let's go with response.add. There's got to be an add function. Didn't we add? Oh no, we can't do this yet because there is no create response. So let's create a method called create response on the packet. Now it's going to be a public packet. We're going to return a packet from this function. Now I like to put the public stuff near the top and leave all the private stuff down the bottom. That's just a personal style thing. So what we want to do is we want to create a new packet. So the response is going to be a new packet. Now the packet itself is, so what we should do is this. Initialization, can we actually go type equals packet type dot. Ooh, this is interesting, right? So we need to make sure that whatever it is we give back is the opposite of what came in. So we should go this dot type. If it is the packet type of, let's say, a request, then we need to set a response type. But if it's not a request, then it could well be a plain request. So it should be a plain request. So we'll create a plain response, right? From there, what else can we do? Once we've created the response, we want to be able to add a TLV to it. So this interface is probably just a little bit crap because not only do we want to be able to add a TLV object, it'd be nice if we had a set of helper functions that would allow us to add based on type. Okay, so I want to be able to say TLV type dot, let's say in this case, what am I going to do? It's a request ID, isn't it? So I'm going to give it a request ID, and I'm going to give it a string, which is this dot request ID. Now, actually, this is interesting. Request ID should always be part of any packet that we've got, whether we've deserialized it or whether we've created a response from an existing serialized packet. That should always be there. So maybe we can do this. We'll create a public string request ID. All right. Now what we want to do is, as part of our getter, it's going to be read only. We're going to go this.tlvs, and we're going to index in with tlv type.request ID, and we're going to take the first. Hang on a second, that should be a list, right? Dot, yep. First, so this needs to include the link, otherwise this magic's not going to work. So first, there we go, dot value as string. Okay, so we're getting the request ID out as a string, and we need to return it. That's why that's not working. And at the same time, we want to make sure that we not only have the request ID, but we have the method, because that's part of every packet. Okay, so that'll be method. Okay, because we're going to use both of those. So the request ID is this dot request ID. Okay, so that's one TLV we want to add by default, and here we also want to add the method and do the same here. But that means we need to overload stuff. Okay, and we can get smart with this. Okay, so we have the ability to add a TLV object if that's something that we already have, which is cool. Now what we want to do is go public void add TLV type, whatever the type is, and let's say a string of value. Now we know if they're giving us a string, then we need to actually bind it to a string type. So what we can probably do is make sure that the TLV type that we are being given has the meta type that maps to a string. So we should probably do some sanity checking. We should be able to go if we're going to need to abstract this in the same way that we did with the validation of the TLV type. How should we do that? Hey Kilix, thanks for coming on, mate. Everyone, welcome Kilix. So here's what we should do. We should delegate the responsibility of this to the TLV itself. So we want to go var TLV equals new TLV. What constructors? Now we've only got a reader, but we want to be able to give it the type and the value. And we then want to be able to add this. So all we need to be able to do is go this dot add. Let's get rid of that. So this is like a cheeky helper. And we're going to replicate this slightly on both the interface for the packet and the interface for the TLVs themselves, right? And what we should probably do in this case is return a reference to the TLV itself, right? So let's do that. TLVs.add. Now this one doesn't make a lot of sense to return whatever it is that we gave it, except for the fact that we should be able to chain this stuff together. So I am going to return the TLV that was passed in. Okay, so that's no big deal. That's no big deal. Now we want to be able to do this for every TLV type that comes in. That means something. So down here, let's go down to, where are we? Add TLV. So we're going to do the same thing here, right? TLV will return the TLV that we were given. And we're going to do the same thing here with a difference. Oops. Okay. Now, actually it's not add, is it? What we want to be able to do is create a new constructor. Oops. We're creating a new constructor. Yeah, that's what we want to do. Create a new constructor. So let's go back up to where the constructors are. Here we go. There's one, there's the other. So we are in exactly the right spot. All right, so we're going to create a TLV based on the type and the value, but we're going to do something just a little bit different. Okay, we are going to go this.type. Where is it? Type equals type. We're going to go this.value equals value. We don't know what the value is at this point. It's not relevant. But what we want to do now is validate type of string. Is that what we want to do? Whoops. Let's make sure that this code is doing what we want it to do. If this value is null, expected type. Yeah, right. Oh no, that's not what we want to do. Validate type does not do what we want to do. We want to validate that the value that we're giving it has the right meta type. So maybe what we should do is go validate meta type and give it string. So we'll do something similar here. Private void validate, meta type. Now the question here is, how do we map from a type? We probably don't. That's right. So this could well be a really, really small function, but I think it's worth putting it in, right? So we need to give it the type, the meta type that we're expecting, and then the TLV type that we've got. But the TLV type is already baked into the current value. So we'll follow the same pattern that we did with the previous type validation and use what's baked in except for what's expected. Okay, so we'll go meta type, expected type. Okay, and then what we'll do is we'll go if this dot value, sorry, not this dot value, this dot type dot to meta type. So we get the meta type out, and if it's not the same as the expected type, sorry, expected type, then we should just do the throw new invalid operation exception. Okay, and we need to pretty much do the same thing here and go expecting meta type whatever we were expecting, but provided type what's it called? It's provided type. No, expected type. This dot type. Yeah, okay, but provided type 1. So we need to give it expected and this dot type. Okay. Hopefully that makes sense. Did I go one too many? Yes, I did. So everyone's really quiet tonight. I'm going to put it down to it being Friday, but there's no banter. More banter. Everyone needs to talk more. Send the abuse. Have a swig of tea, etc. It's more disconcerting when everyone's quiet. I much prefer it when everyone's trolling me, strangely enough. Anyway, so when we create an instance of a TLV using that, so instead of this, I want to go meta type dot string. So we are expecting the current setup to have a meta type of string. Okay, and that should barf if what we give it is not a type of string. So here we want to do the same thing. We can go uint 32 and change this to dword. We can do, oops. We can do the same thing. I've buggered something up, haven't I? There we go. Meta type dot, what's wrong with that? Meta type does not contain, doesn't it? uint, not dword, bugger. Is that what we call it? Yeah, it is too. Keyword, and that's going to be a uint 64. Nerd. There you go. Something about get system. Oh, someone had to do it. But that's fine. That's absolutely fine. Now, we'll handle the group case in just a minute, but I don't think we should be able to, we should construct TLVs that have groups. We should generate those on the fly. That's what I'm thinking anyway. So we've got string. We also need a byte array. So this is going to be raw. What else have we got? Oops. Let's just quickly check the raw types that we're happy to support. We're not going to deal with groups yet. Bool. We need bool. Bool. And I think there was one more, wasn't there? Oops. Raw, string, keyword, uint. No, there wasn't another one. Okay, so that should mean that we have the ability to create TLVs of a certain type based on the value that's come in. Now, we're going to use overloading here as well. Add, because this has got effectively the same thing. So we can go bool. We can go byte array. Oops. Yep. We can go, what have we got? String bool. We can go uint 32. We can go, crap. What did I do? There we go. Uint 64. 1, 2, 3, 4. That's all we did, isn't it? String, uint 64, byte and bool. String, bool, byte, uint. Yeah, okay, so those 5. And we'll deal with the complex, the group related stuff in just a minute. Now this is the reason why I actually wanted to return the TLV to the caller in cases where groups are created. So what we want to be able to do is go public TLV, add group, and give it a TLV type. Okay? And we're going to do exactly the same as we did with all the other stuff. The only difference is that we don't have a value. Okay? The difference here is we are going to assume that if we construct the TLV with a type, then, well, can we make any assumptions? At the moment, we don't have the ability to set the value directly, but maybe that is something that we want to be able to do. Maybe not. But what I'm going to do for now is I'm actually not going to validate the meta type of this one. I'm going to go public TLV, TLV type.type, and we're just going to set that. And we're going to leave the value blank. Because when we call this, we're actually going to add values to the subgroup, right? This is moderately easy to follow after watching a few hours of Shish. Oh, excellent. That's good to hear. All right, so now we have the ability to create a response. Response.add. So let's go with, let's create a very simple case here. So we've got to create a TLV type. Let's just give it a channel ID. And that's a uint, so we can, let's just give it 10. Okay, and let's see if this actually behaves. Let's create a encrypted symmetric key. Now that's expecting a, what is an encrypted symmetric key again? It is a raw, so let's go new byte and give it 1, 2, 3, 4 as the value. Okay, so there's 4 bytes. And then let's go with group equals response.add group. TLV type dot. Let's go with something that we know is a group. What do we got? Are any of these a group? We may not actually have the need for any groups at this level, but let's have a look. Let's go to the definition of TLV types and see if there are any groups in here. Here you go. Exception. Exception is a group. Channel data group is a group. That might be it. Transport group. There you go. So transport group, which makes a lot more sense. Because in each transport, like you can have a set of transports, right? So you can return, basically there is a core TLV request that says, give me a list of all the transports that you've got. And so from here, we want to be able to go group.add and do exactly the same thing directly on the TLV. So, we need to go back down here. You see that we've got all these constructors here. We do need add functions that will do exactly the same thing as what we do at the packet level. The difference here will be that if we have something attempt to add a TLV when it's not a group, then it should it should buff. So let's do this here. Now, we want to add, not just new TLV, that's correct. We want to validate metatype of metatype.group. And we want to do this for all of these cases, because we want to make sure that if someone's adding a TLV to the current TLV, that we're not doing it unless it's a group. Oops. Yep, so let's take that out and we'll do it here as well. So if you're adding a TLV to a TLV, the current one needs to be a group, which I think is reasonable. All right. So here, let's add a TLV type dot trans. Let's go with trans URL. And here we'll just go something like https foo.com/bar. So that's an example of a transport URL. We can do the same thing with a transport retry wait. Transport retry wait, I think, is a uint. Yes, it is. So that tells the transport how many seconds to wait between attempts to reconnect on the current transport. So let's go with, I don't know, 40 seconds? 40 seconds. Let's get rid of that, eh? We can also go trans retry total. How long should we be trying for? So we could go for something like 360 seconds. Okay, and that's basically how we should expect to sort of generate the packets on the fly. All right, so at this point we should be able to serialize the packet. So let's go with I'll call it packet data this time. Packet data equals request dot, let's go with to raw. I think that's fine, don't you? Because that's what we're converting it to, and that should return a byte array. And we should be able to do the exact opposite. So let's go to the definition of that. We are going to go and return a byte array. And this is where it's going to start getting fun. Now, that's because it's public. Let's move it back up to where all the other public stuff's going on. Let's go here. Ooh, check this out. I forgot to go return response. All right, to raw. So this is where we need to be able to create a binary writer. We did the binary reader before, and now we want to do like a binary writer. So if we look down to, where did we do it? Parse data, which was internal. We may not need to actually have anything other than a top level function for this, because there's really only one entry point to this. So let's go with using var writer equals new binary writer. Now I'm assuming it's going to want to stream. Yep. So let's create one. And it's going to be a memory stream. Var stream equals new memory stream. Now, what are the overloads? Buffer capacity. Initialize new instance of class with expandable capacity. Initialize as a specific. Okay, so I think we should use that one because we don't know how long things are going to be, but we do know how long things will be as a bare minimum, which should include, let's say 4 bytes. No, sorry, not 4 bytes. A string that contains the request ID and a string that contains the method. And that could be, I don't know, somewhere around the, how long is the request ID? It's like 16 characters. And there's going to be, I don't know, core underscore something or other. So let's just, for now, we'll put it as 20. For no other reason than we actually do want to pre-allocate something. Now when we're done, we want to go return stream.toArray, which will give us the byte string, okay? For whatever happens to have been written to the memory stream at that point. Okay, so what we want to do now is we want to serialize all of the TLVs in our current dictionary. Okay, so we should be able to do this. First of all, we've got to iterate over them. Okay, so for each var TLV in Oh, no, we won't call it TLV. We'll call it item in this.tlvs. So we should iterate over the entire dictionary. We should be able to go. Actually, we don't even need to because the keys for each of these things are the types, and the types are baked into the TLV at the same time. We should be able to just go through the values. Okay, so that will give us a TLV itself. Right? So TLV dot to raw. We'll give it. We'll call it to raw, and we're going to write that directly. So rather than give it the writer to write to, actually, you know what? It would make way more sense if we gave it the writer to write to, because then we don't have to create subwriters and return lots of dynamic arrays. We can just keep writing to the same packet, or can we? This is interesting. So what we want to be able to do at the top level is we need to be able to, we've got to serialize whatever TLVs there are. And once we've serialized that, we need a length. We need to get the length of the data and we need to bake that in. So this isn't as simple as I was expecting. I was thinking we should be able to just recursively pass in a writer and everything be fine, but that's not fine. So we will have to get the information back out of the call that we were expecting, and then based on whatever that type happens to be, we can prepend bits and pieces as we see fit. So what I think I might do is, instead of calling this just stream, because this is TLV specific, right? I'm going to call this the TLV stream. Okay. Now, for the TLV stream, I am going to pass that reference into every single TLV. So, TLV dot to raw will give it the writer. Okay. Now, once that's been written, once all the TLV information has been written to the stream, we've got to extract it. Okay, so let's go var TLV data equals a default of a byte array. And then once we get down to here, we want to be able to go TLV data equals TLV stream dot to array. So we actually extract all the TLV information. Now, this is the trick, right? We're going to have to create another set of writers. So this time we're going to have the packet stream. Okay. Now we don't know how big this is going to be. Oh, actually we do, because we can go TLV data dot length, whatever the length is, plus we know the size of our header. So there's 4 bytes for an XOR key. We need we need 4 bytes for an XOR key. We need 16 bytes for the session GUID. We need 4 bytes for encryption, 4 bytes for length, and 4 bytes for the type, right? So that's 4, 16, and 3 4s. So that's 28 bytes, right? Oh no. 4 4s. Yeah, 4 4s. So 32 bytes for the header. Okay, so we're just going to hard code that for now. And that should hopefully be enough. And so what we're going to do at this point is we're going to start with the XOR key. Now, the XOR key we're deliberately leaving blank at this point. Okay? And I will explain why afterwards. So let's go writer dot write. We want to give... Now remember, we're in the world where our integers don't map correctly. So rather than give it a byte array, packet. Packed it. Did I write packed it? Oh, I did too. Thank you. Thanks, Mongo. I'm such a noob. Let's put packet stream here. Now, I'm going to have to put an extension on the binary writer. Let's go to our binary reader extensions, which for some reason isn't happy either. Let's do this. Binary CTE writer extensions. Let's move that to another file. Binary writer. Yes, just crikey. Public static. Void write. I didn't call it D word, didn't I? Is that what I called it? We've got read D word, and it's not actually a D word. We call it uint in our type. I'll leave it as D word for now. It's not really going to matter too much. So we'll write a D word. This binary writer. Let's add that as a reference writer. Now we want to do the opposite of what we did before. So we want to go writer.write. And instead of bool, we've got a uint. We're going to take whatever the value is that we create, which is a uint32. We've got IP address in system.net. We're going to go host to network order. We're going to cast the D word, which is a uint32. Right, D word, I'll call it value. I like calling things the value that we're actually writing. Network host order, we've got to cast this to an integer. So value, and then cast the result back, like so. I missed you guys, glad to be back. Nolcol, greetings to you, sir. How are you? I hope everything's good. So we're going to need a couple of other extensions. While we're here, we may as well whack them straight out. So we're going to write a keyword at the same time. A keyword, and we're changing all instances of 32 to 64, and int needs to be a long. Okay, so now we can write D words and keywords with the byte orders being preserved. We're probably going to need to do something special with write string as well, right? Because remember, when we read the string, we basically pull out. Let's go to the binary reader. We don't. That's right. We cheat. Let's go back to our TLV, where we read the string. Where is it? It's up here, isn't it? See how we trim end? I'm going to remove this. And what I'm going to do is go this.value equals reader.read string int length. Actually, yeah, int length. We'll keep that consistent, right? We'll take that out and we'll make that an extension, because I think that makes a bit more sense given that we're putting all of these extensions in here. So if we go public static string read string this binary reader, okay, then we should be able to go return encoding, which needs to be added as a reference, dot utf8 dot get string reader dot read bytes, give it the length, int length, give it the length, not read byte, read bytes length. Okay, we get that, and then we go trim end and get rid of the null byte. So we leave that as an extension method. What have I done? Oh, I deleted the name of the class rather than copied it. That's because I'm stupid. Let's put that back. Change that back to reader. Okay, my bad. Sorry about that. Is this going to replace the default read string method? Yes. Well, I should hope so. But that's a bloody good question, because there is a read string method, isn't there? Let's have a look. +1 overload. So I think the extension methods will by default hijack it, but let's do some testing and find out. So we've got read, write D word, write keyword, public static void write string this binary writer string value. So this time we want to go writer.write. we want to take the value. We also want to add a null byte to the end, right? No, that's not what we want to do. We want to write encoding system.text.encoding. Oh, I've got a new follow. Hello, Matthew Hulse. Thank you for the follow, mate. It's glad. I'm very happy to have you on stream. How many we got? We're getting close to 20, which for me is good for a Friday night. Oh, look, there's some other interesting names in here, including Buster B. So for those people who don't know, Buster B. Cook, Brent Cook, the man with the plan, based over in Austin in Texas, who works at Rapid 7 and is a shining beacon of intelligence, and a wonderful human, fantastic dude to work with, who I'll be catching up with at the end of this month at the Metasploit Hackathon over in the USA. If you guys have any love for Meterpreter and the work that's been done recently on Metal, which has become, you know, the Nix-based Meterpreter, he is the man to thank. He is fantastic. So thanks for joining in, Brent. It's great to have you here, mate. Okay, so encoding.getBytes. No, encoding.utf8.getBytes. And the string that we want to give it is value plus the null terminator. There he is. I've busted your cover, my friend. It was all in the name. Right keyword, dword, string. Now, bools are bytes, so we don't need to overwrite those. Raw can remain the same. I think that's basically all we need to worry about. Okay, so let's go to packet, back to packet. Writer.write. Now, what are we writing? We're writing a D word, and the value that we're going to give it is 0. Now, this is me being cheeky. Write a 0 XOR key. So I'm just writing a blank XOR key. And then I'm going to write a blank session GUID. Now, this is also cheeky. What I'm going to do is I'm going to write 2 keywords, because that's 16 bytes. We're going to come back to that later. Okay, this is just for the sake of having a blank session GUID. Later on, when we actually create a raw packet, we're going to be maintaining behind the scenes some semblance of what the session encryption level is and passing that information into this to raw method, and we'll be giving the session GUID at the same time. Actually, you know what? Maybe we can do this already. Byte array session GUID. Let's pass it in here. Why not? So writer.write session GUID, and we'll pass it in from our test. This needs to be to array. Right, so we write a blank XOR key, and then we write the session GUID. Then we need to put encryption information in, which for now is going to be blank. Write a not. Actually, we'll write enc none, which is effectively 0 at this point. We'll come to this again later on as the encryption flags, and then we need the length of the packet and the type. So we want to go writer.write dword. We want to give it the TLV data.length plus 8, remember? Because the 8's going to include the length value itself and the type. What's going on? This is a typecast problem. Let's cast that to a uint32, and that should be fine. Specify the TLV data length, and then finally the type. Specify the type. This is probably a superfluous comment which we'll end up removing at some point, but we'll leave it in for now. Okay, I should probably put use in here for the sake of being 100% clear. Now the type is this dot type. Now that is a uint value, so maybe what we need to do is go write packet type. And the packet type is exactly the same thing, right? It's just casted. public static void write packet type to this binary writer packet type. We're going to do exactly the same as a dword. So this will be writer.write dword. The only difference is that we're just going to cast this straight to a uint32. Okay, and we're going to need to do exactly the same with TLV types. So let's chuck that in at the same time. All right, so now that we can specify the type. Now once we've done that, we should get a full array that we can then pass back, except for one small thing. So let's do the same. We're going to need a packet data equals default byte array, like so. And here we're going to go packet data equals this. Now by coming out of scope, this is important, right? You see how we've got these using scopes? We're doing exactly the same thing here. We're using and we store a reference to the array in a wider scoped variable. We're doing exactly the same thing here with a wider scope variable. In fact, technically, I could put this in here. But this would be a TLV writer. Where are we? Like so. The only problem is that we would have to get rid of this, which isn't really a problem. Anyway, to cheat, to get our formatting back, we can just get Visual Studio to do it for us. So by the time we get here, we should have a fully serialized packet once we've implemented the stuff on the TLV side. Once we've got that packet, we actually want to do the XORing. But first of all, we need to generate an XOR key. So let's go var XOR key equals generate XOR key. Now this is going to be a private method for now. Private byte array generate. Oh, come on. One of my shortcut keys didn't work. So let's go tools, options. Where are we? Keyboard. Let's go vimu.keypress ctrln. So when I press Control N in the text editor, what happens? Oh, it's actually bound. That's interesting. Because if I press Control N in Vim, for those who don't know, when you press Control N in Vim, what it does is it looks at the string that you're currently working on, and it tries to do a substring match against other strings in the current file. So that means if you've got a word inside a string or a word inside a method call that doesn't yet exist, IntelliSense won't find it, but Control N should. But it's not working. I don't know why. That's very frustrating. I will worry about that later on. But that's one of the lovely hacks that that Vim does that you don't get in any other, or at least, to my knowledge, any text editor that's like Visual Studio. Alright, so all we want to do is go var XOR key. Ah, no we don't. We want to generate random bytes. Now, we want to generate cryptographically secure random bytes. So, .NET cryptography generate random bytes. It's something I can't remember exactly what it is, but here you go. RNG crypto service provider. That's what we want. So all we need to do is create one of these puppies, and then we just call get bytes. Right? So that's one of these babies here. I don't know how expensive it is to create these, but I'm pretty sure it would be okay to leave one per packet, right? So let's do this. This is one of the lazy ways that you can use, and when I say lazy, I mean super lazy. Let's go private, or whatever. Ooh, didn't copy it properly, did I? God, there's a very cheesy song playing in the background. Sorry about that. There we go. Crypto, RNG provider. let's call it random. Random. Okay. Now, as part of our getter, we're just going to do a lazy creator. Okay. So if this dot random, which is going to be one of these. Some people don't like this approach, by the way. Random equals null. Always initialize to null. If it's null, then we'll create it. This dot random equals new, whatever it is, and then we'll return it. Because that will give us the ability to call on it when we need it and not before. Okay. So when we generate our XOR key, got a question? It sounded very jingle bellsy, didn't it? I'm sorry about that. We want to go return this dot random, which will create it for us if it doesn't exist. Get bytes. Ah, we've got to create it. So we want to go var bytes equals new byte 4. Now remember, XOR key is going to be 4. So we'll give it the bytes. Do we have to give it ref or something? No. And then return the bytes. So that will generate our random XOR key. We have another follow. Welcome. Thank you for the follow. I very much appreciate it, as always. So now we have our XOR key. We should be able to, this is the beauty of being lazy and specifying blank / null as the first part of the XOR key, is when we XOR the entire payload, by default, we bake the XOR key into the start of the payload. So all we need to do is go XOR bytes, give it the XOR key and the packet data, ref, and then return packet data. Come on. Simple as that, right? So this magic will literally just bake the XOR key into the thing for us. We should see a bunch of repeating nonsense to begin with. Okay? So what should happen now is that to raw should crap itself because TLV doesn't have a to raw method. So let's create one. Ugh. Alright, fine. Viz Studio, you don't want to play nice. We'll do it ourselves. Public byte array to... Oh no, we don't want byte array, do we? We just want to go public void to raw. Is that what we want to do? Yeah. To raw, and we'll get a binary writer. So this is where we're writing to. Okay? So, we want to effectively do a similar thing to this, right? So if we are a nested group, we've got to behave in a certain way. If not, we're going to behave in a different way. Okay? But it means that there's going to be a bit of duplication. We are going to have a stream for the sub TLVs. We're going to have a stream for our own, for our length and our own type. And that length and type is going to be there regardless, right? But we do need to behave slightly differently. So what I'm going to do is I'm going to take this code here. And yes, it's a little bit of copy and paste, but it's in the name of something. So here we'll go. We'll call it the, I'll just call this stream because whatever it is, it's the current stream for the current packet. So we'll just call it stream. Memory stream. Now we know it's going to be at least 8. Always going to be at least 8. And then we'll call that stream, and we'll just call that writer. So from here, why is that complaining? Local parameter named writer cannot be declared in scope because that name is already used in enclosing. Ah, yeah, right. Is it? Ah, that's right. We've already been given a writer to write to, so we only need one extra. Okay, this is where I'm stupid. So let's take this. So if this dot type to meta type equals meta type dot group. So if we've got a group TLV, we need to behave in a certain way. else we're going to behave in a very different way. Now, the length and value will behave exactly the same way, but we again don't know the length until after the fact, right? So we've got our extra TLV data, etc. And we're going to do exactly the same thing as we did before, right? And we're going to basically recursively call to raw on each one of the TLVs that we have, okay? Now why this is complaining, I don't know. List TLV doesn't have... Oh yeah, we've got a map. We've got to map it, don't we? Now we could use links, so that's why this is complaining up here. Okay, so let's go back up here. We could get tricky with some link, right? So we could go this.tlvs .values can we map? Or we should go select, which is effectively the same thing. Oh no, let's go for each. Yeah, no, actually I'm gonna think twice about that. So let's just iterate over all of the TLVs in the list in a very simple manner. Okay, so what we're gonna do is add another follower. Thank you to Tim Oles. Appreciate the follow. So for each, now this is, we're gonna call that list. So for each var TLV in list, if I could type properly, this is where we want to go and do this. Does that make sense? So I guess what we could actually do is select many, which is pretty interesting because we'll get a list of TLVs, and then that would allow us just to give the identity function, which should flatten the list. Hang on a second, this.tlv.values. There is no flatten, that's right, there is no flatten method. So, can anyone tell me what I've just done here? Because that, particularly for the people who haven't done any functional programming before, that's probably going to look a little bit alien. Does anyone want to take a stab? Is anyone confused, or does everyone know exactly what this does? I'll take a swig of tea while I wait for any comment whatsoever. You're tilted. Okay, so what I'm going to do is I'm actually going to create another extension method just so that I can explain this in a little bit. Default takes non-null values. No. Okay, so this is wonderful. I do love this little hack. So I'm going to call this IEnumerable T. Extensions of type T. Okay? T doesn't matter. All right? So this means we're going to allow for a public static IEnumerable of T. This IEnumerable, is it IEnumerable? I'm pretty sure it's IEnumerable. Yeah, a generic collection of elements, right? And we're going to call this flatten. This makes a pretty gross assumption. All right. Let's see what happens when we do this. IEnumerable. There we go. Return elements dot select INELink. Elements dot select many. Now this should not work as part of a... See how this isn't working? And the reason why it's saying that is because we need to make sure that whatever's inside is of type list. And then I'll explain why. Need to put T there as well, otherwise the type system shits itself. So this.IEnumerable of, I wonder if this works. This has got something to do with covariance and contravariance. There we go. Now we need to know if we take this out, this.values.flatten. And we need to add using met.core. Oh no, it should be fine. Oh, I think the problem we've got here is that an IEnumerable. It returns a values collection containing. It's a value collection. So if we went as enumerable, can we flatten that? What does as enumerable return? IEnumerable of list of t. So I wonder if we need to be able to do this because of the covariance / contravariance issue. So if we had an IEnumerable of list of t, can we flatten that? Yeah, we can. So that means we should also be able to do the same with something like a value collection, which is part of the dictionary. Is that what it was? I will explain this in just a minute once I've got this extension method set up. IEnumerable values is a dictionary collection. Yeah, okay, I can't do that. So I do have to make sure that it is of type enumerable. Values.as flatten. Is that going to work? I think it is. Okay. Does that make perfect sense? Does anyone have any questions? Did I just pass 1,000 followers? Wow, I did. 1,002 followers. That's fantastic. I feel really special now. Okay, so let me explain the whys and the whats of what it is that I'm doing here, right? So as we can see, based on the type system, this.tlvs is a dictionary of TLV types to a list of TLVs, right? Thank you. Thanks for Kilix. So for when I say .values, okay, what we're doing is we're getting a list of values of the dictionary, okay? So it's basically chucking away the keys and it's giving us all the values in the dictionary because we don't care about the keys at this point. Now, each one of the values in our dictionary is a list. So what we have here is a list of lists, okay? Most of the lists will contain just one element. But in cases where we don't, we will have multiple elements, right? So what I want to be able to do is take the list of lists and just convert them into one list. So if we've got a list with A, B, and C, and a list with D, E, and F, I want to take those two separate lists out of their container list and join them together. So I'm effectively taking a list of lists and creating a list, right? And we end up with A, B, C, D, E, F as one list, all right? So flattening a list is the same as taking one level of a list away. So if you've got a list of lists, you end up with just a list. If you have a list of lists, then flattening it will take it to a list of lists. So you're kind of just removing one layer of lists, okay? Now, unfortunately, there is no built-in flatten function, which is why we've just created one. Now, the confusing part about this is this little doohickey here. So select many. In Link, you can have a list of elements or an enumerable of elements. Yes, exactly that, Mongo. That's a perfect example. So maybe I can provide another comment here. So if we have a list with 1, 2, 3 in it, and 4, 5, 6 in it, okay? If we flatten it, we end up with this. I can't type, can I? So that's basically what flattening does, okay? Simple as that. Your example is perfect, but I thought I'd chuck it on screen as well so people could see. So that's what flattening does. Now, there is no flatten function, but what we have the ability to do is select. Now, select basically does exactly the same as mapping in functional programming. So you can say, right, across this list of elements or this enumeration of elements, I want you to apply a function to it, okay? Now that function in C# can be specified as a lambda, and that's a lambda expression there. So if I went select, now on this particular list, we don't know what the type is, but let's say whatever that element is, let's say we wanted to convert it to string. We could go x dot to string. Okay, and that creates a list of strings out of the list of whatever happens to be in it. Now, so that should be fairly simple to grasp. We're just iterating over a list, applying a function to every single one of those elements and creating a new list. And by list, what I mean is like a lazy sequence of values. Okay. Now, the difference between select, if you have a look at the type, select expects the list that you're going over, and a function that takes an element of those lists and returns a result. So a map from A to B of some kind, okay? Difference with select many, okay, is what it does is it does exactly the same thing, but it expects the function that you are giving it to receive a list of elements and not just a single element. Okay? So what I'm saying here, and it will create a new list out of whatever you give it. So here you could go select many, and what you're doing is you're actually applying a function to every element, to the list of lists. And what I'm saying is, well, I actually don't want you to do anything other than just be yourselves. So I'm saying whatever element you give us, return the element as it currently stands. So that's known as ID. That's the ID function. You could go public T ID like this, and you get an element of type T, and you could just return T. So this is what the ID function does. It literally takes whatever it is you give it and returns it. ID cannot declare an instance method in a... Okay, so public static. Shut up. So there you go. That's the ID function. And this would be the same as just going ID. Take what we've been given and pass it back. And the select many then flattens those lists together. So I'm just abusing the fact that I can use select many in conjunction with the identity function to flatten a list one level. Then at this point, you can see the type system has said, oh, I know that this is going to be a TLV. It's just a flattened list of TLVs. And it should all be lazy, which means that it kind of generates it on the fly as we're iterating over it. Okay? Now we should be able to do exactly the same here. Now, why isn't this one happy? Do we need a link in here as well? Flatten. Oops. There you go, it's happy now. Does that make sense? We're only flattening one level. Exactly. Exactly that. Now, have we still got a compiler error somewhere? We do. Yes, we've got to give it a session GUID. So all I'm going to do is I'm just going to create a new byte array that is 16 bytes. We'll just initialize it to 0. I think it by default will initialize to 0. I don't want to have to type in. Okay. Oops. 14 dot. There we go. Is that going to work, or do I need to give it one more? How many have I given it? 4, 8, 12. So I gave it too many. That's what happens when your vimfoo is weak. Okay? It's not recursive, Gombos. It's just one level. If you want to make it recursive, you're in a world of hurt. Okay, so, but this is interesting, right? What I'm going to do at this point, we can actually run this code now, which is kind of exciting. But first of all, we want to make sure that our packets have been deserialized properly, because remember we changed the string parsing? What happens when we run it? Let's have a look. Looks like this has come out correctly. Looks pretty good to me. We are an hour and 15 in already. Can you believe it? Righto. So we're going to create a new packet. This request has the deserialized stuff in it. And then we're going to create a response from it. Let's have a look. We create a response packet, and that response, what does it have? It has the type response, which is exactly what we want. It doesn't have a value. And then we're going to add, what happened here? Your step in request pulled on a step over a property operator. This behavior. Do you want to continue being notified when automatic step over happens? No, I don't. Okay, so that's just telling me that it's stepping over a property getter / setter for us. Okay, so we are currently creating a new TLV of type request ID with a value of whatever the request ID that came in. And now we're going to validate that the meta type's correct, which it is. Okay, that's good. And then we just add it to the TLV list. We do the same for the method. Okay, so according to our quick look, our response, it has two TLVs. One of them is a request ID, one of them's a method, which is cool. Okay, so I'm just going to add a couple more. There you go, there's 4. And then we're going to add a group. And so from here, there's the group and there's 5 elements. Oops. What did I just do? Is that out TLVs? Oh, null reference exception. Isn't that interesting? Ah, you know what I did? Can anyone tell me why we got a null reference exception? Because I know. Because we didn't do this. For each one of our constructors, we need to make sure that we call the base / default constructor. Otherwise, we don't end up with a properly initialized object. Now, we've actually missed this, haven't we? We need to serialize each individual type. Now, at this point, we've actually got all the TLV data that we want. So we should be able to go and do this. So let's go object value to, oh no, we can't do that. We can't do that. Ignore me. We can't do that. That's nonsense, people. Nonsense. Jeez. We want to go writer.write. Now we're writing the length. Okay, so that's the D word of TLV data.length. Okay, but we need to cast that as a uint 32. Now we could also actually remove this problem by adding an overload for this D word that doesn't just take a uint value, but an int value. And then that covers both cases. So that probably makes the most sense. Okay, so we write the length. Then we need to write the type. Writer.write. What is it? It's TLV type, isn't it? Are we in TLV? Yeah, we are. Write TLV type. I thought we'd already done an extension for that. Write TLV type. There it is. Yeah, it is there. This dot type. Okay, and then finally writer.write. What would it be? It'd be bytes. And the bytes we're going to give it, TLV data. Why is this not happy? Could not be found. That's pretty interesting, isn't it? Right, byte, buffer. There it is. Oh, it's just write. It's not write bytes, it's just write. What a noob. Okay, so that solves the group TLV problem. basically what we want to do here now is we want to do exactly the same thing depending on the type that we're writing. Okay? So we're going to have to do a case like what we did before. So select this dot type dot to meta type. We want to have a look at the meta type of each one of these things. What am I going to select? Is that what I want to do? Switch. Crikey, it's like I'm writing VB. What a noob. So case meta type dot. Let's go. We'll start with bool. Okay, break. Now this is where we're going to do some casting again, right? Now we know that a boolean is going to be of length 1. Okay, so we want to go writer.write dword the length of 1. Okay, we know that a boolean is just 1. Then we need to go writer.write TLV type this dot type. Yeah? Are you making an aimbot? I'm afraid not, my friend. We are definitely not making an aimbot. This is one of the few cases where I wish we kind of had length after the type rather than before, but what are you going to do? Because we could put the TLV type right at the top and it would cater for all cases where it's kind of interleaved. So here we want to be able to go right and cast this to a boolean with this dot value. We could go value as bool. Actually, I'm going to leave it as value as bool, because that'll add the validation at the same time, right? Could always write another stream first, similar to what you do for the group case. The problem with that is that we don't know the length, and the length comes first. We have to write the length, and because a byte's 1 byte, dword's 4 bytes, we need to know all of those things separately. Free Robux hacks? No, mate, we're building a .NET rat. Who is it that loves it when I say rat? I'm sure someone out there does. uint. So we know that's 4. This dot type. Value as, what did I call it? Was it dword? Rat. Hey, that's right. It's you, Aaron. It's you. You love it. Okay, so keyword. We need to do the same. Dword. This time it's 8 bytes. And this is going to be value as keyword. Now we don't have to do any magic with those types, do we? Yeah, we do. Right. This needs to be keyword. Remember, we've got some magic there. Right. dword. Okay, so now we've got string, and that needs to be right string. This dot value as string. Now we need to put in, this is interesting, because we know that we have to put this dot val, actually we'll go val equals this dot value as string. We have to go val dot length plus 1 because we need the null byte, remember? And so in here we can go val. And then finally, case meta type dot, what are we doing? Raw. How are we going to handle this case? Writer dot write. Let's take a copy of these again because we're lazy. A rat. You're going to rat people. Yeah, basically. New version of Meterpreter. Thank you, Gombos. I meant like writing a different memory stream, then at the end take its length and write to the final stream and then the actual data. That's exactly what we're doing. That is exactly what we're currently doing. Hack Facebook in C#. Such a troll, bro. Val equals, sorry, val equals this dot value as raw. That unboxes, and then we can go right dword val.length. We don't need to add a null byte this time. We can add the type, and then we can go right just the bytes. You guys. Alright, so the other cases with the meta types, including complex, compressed. For now, I'm just going to ignore them. And default. What did we do with defaults when we were reading? Anyone remember? Where ist the code? Ah, we've got these. This is what we should do here. Not that we should ever get to this point, given that we should end up with more sense. Excuse me? Ugh. That was like a half sneeze. Excuse me. Gonna get minted. Savage. Savage. This. Hang on, let's convert this up here because we are using it in multiple cases, right? So var meta type equals this type dot to meta type. Okay, let's go meta type, and we'll do the same in here. Meta type, meet type, meta type, and then this code down here should work. Sorry, don't support. Whoa, what is? Why have we only got this? That's wrong. Is that what we had down in the other spot as well? No, I just mucked it. Okay. Ooh. Don't krebs me, bro. Don't krebs me. Alright, let's try this again. Let's see what happens. Now we know that creating of all of these things worked fine. Now we want to make sure that when we add each of these things to the group packet that we end up with exactly what we would expect in the group. So trans URL, reach, blah, blah, blah. So that's good. And then in the response, we should also see that there's a TLV for the group. Right. Let's see what happens. Packet data, packet stream, writer. Let's create our subwriter and let's see if our flatten code actually works. Flatten TLV to raw. So our current TLV, this is of type negotiate TLV encryption, which is exactly what the request was that we mapped this from. There are no sub TLVs. It is of type method. So we should see that go through the process of being compared as a string. So we get the value as a string, which is, let's do it in intermediate. You can see core negotiate TLV encryption. We write length plus 1, which is 29. Write the TLV type, write the string, done. That's pretty good. So let's just iterate over these. And see what what were we in? Oh, that was in packet. Did I do them all? Let's have a look. So our TLV data, 539 bytes. Okay, so now we're going to write all the blanks and generate an XOR key. It should be 4 random bytes. There we go, 4 random bytes. And then we're going to XOR the entire packet data. Now what does this look like? Boom. You should see some repeating sequences at the start. 44, 121, 6, 186, blah, 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 blah. All right. That actually looked like it's going okay, right? But I'm going to deserialize a packet that we've just serialized. var deserialized packet equals new packet data. See what happens here. Gonna make some stickers. Really, some stickers. Wouldn't a good test be to deserialize some packets, the ones you already have copied over, and then reserialize them, compare the output? Yes, that's exactly what I'm going to do. Pardon me. I will do exactly that. I just wanted to see that the request response mapping also worked. So let's get rid of all the breakpoints and let's see what happens when we deserialize the packet that we've just serialized. Okay, so we've got a request packet that has no TLVs. It's definitely a request though. Isn't that interesting? Why is that the case? Love it when shit breaks. Okay, let's have a look. Let's take the XOR key, which is that. And let's have a quick look at the data and let's see. It looks like it's repeating okay. And we'll parse the data. Okay. Now looks like we've kind of de-XOR'd a bunch of stuff. Did I do something silly over here? No? No, that's fine. Okay, so we seek to 28 and we get a type. What does the type say? Request. Is it a request? It shouldn't be a request, should it? It should be a response. So this is incorrect. Okay, so let's go back here and just make sure that what we're doing makes sense. So, we're doing all the sub TLV data first. Okay, so we're passing in TLV writer to all of these. We get the TLV data out of it, which is 539 bytes in length. Then in our parent writer, which is here, the actual writer itself shouldn't have any data written to it. Length 0, position 0, capacity 32. Okay, so if we write a D word, we should have 4. So our underlying non-public members, we should see a buffer that's got 4 null bytes written to it. Then 16 null bytes. TLV data length is not what comes next. What am I doing? I missed a line. I was right, but we had already written the enc value. Okay, so this writer, sorry about that, base stream, non-public, buffer. So here we should start seeing some values change because the length of the TLV data is 539 plus 8. There we go. So it did write a value there. This dot type is request, which is, it is a request. Why is it a request? It shouldn't be a request. It should be a response. What did I do? Have I done something simply incorrect here? Packet data, request, response. Oh, look at that, request.to_raw. We are trying to deserialize the response. This does highlight an issue though, because we should be able to deserialize, sorry, I should say reserialize the request. And that's kind of what, yeah. I've conflated a couple of things here, haven't I? Right. Let's leave that as is and go back to focusing on response.to_raw. Okay. And let's see if this craps out. Because it doesn't look like we did any sort of sub TLV packet parsing anyway, did we? So what do we got here? Let's have a look. TLV type is request ID. We can see it there. I know it's a bit small. I can't change the font size. Method is negotiate TLV encryption. Here we've got the encoded symmetric key, which has a 4-byte value of 1234, which is exactly what we did. Let's just make sure that's going through and doing what we should expect. Yep, that's looking good. And then we should end up with a group. Oh no, that's the channel ID, yep. So channel ID and the group. Okay, let's step into this one because this is interesting. Is it a group? Yes, it is. Now let's create a sub writer. Do the same thing. This TLV is a URL. We can see that down the bottom. It's got the URL in it. Retry weight. Retry total. Get the array out. Write the length as a D word. Write the type, which is a trans group. And 52 bytes for the total value. Okay. So from there we get the data to come out, which is 163 bytes, which makes a bit more sense. We write this blank XOR key, blank session GUID, the blank encryption, then we specify the length. The type should be a response this time. Serialize, generate XOR key, return the packet data. Okay. Now let's see what happens when we go in reverse. When we deserialize the packet that we've just serialized. Let's have a look. So our XOR key, which we would expect to be 158.199, which is the same as here. What happens? There you go. We've XORed all the bytes, so we should see, look at that, 171 and some other data. It stops at 32 bytes by default in this visualization tool. So let's see what happens when we parse it. Seek to 28 bytes in and read the type, which is now a response, which is great. So let's... Well, isn't that interesting? Aha! $32 bytes. Have I done something silly by limiting or specifying the initial size of these memory streams? I bet you that's what it is. Let's just check. But I haven't done that anywhere else. Memory stream reader.read bytes in .length. So this was in the reader, which we've already tested. Let's just get rid of these limitations. See what happens now. Packet data. 32 bytes. Why is it still only 32 bytes? That's really interesting. So, clearly what I'm missing here is, what I want in my memory stream is the ability to write more than 32 bytes. Because clearly, like the TLV data, what have I missed? Ah, that's what I've missed. After writing the length and the type, we've actually got to write the TLV data into it. Beautiful. Did I do the same here? No, I actually did it here. I didn't do it here. Well, that makes a lot more sense, doesn't it? Okay, so packet data should be a bit bigger now. 195 bytes. That makes a lot more sense. All right, let's live dangerously. So our packet data now is 195 bytes long, which is exactly what it should be. Let's deserialize it. What happens? Ooh, look at that unexpected meta type. Cool. That's really good because our validation of the packet is clearly working. So let's have a look. You got to run. Okay, thanks Mongo. Appreciate you coming along, man. We're going to finish up very soon anyway. Okay, so let's see where this deserialization fails. Parse data. So the type is coming out as a response and it's not finished, so now we're going to read something. Length is 25. Interesting. Type. Meta type none. Why is that? Why is that? Oh, hang on. I think I've just realized something here. So when we serialize and we're doing the length, so where's that to raw function? To raw. Data length +8, so that's correct. Aha! There's something else I've forgotten in writing of the TLVs. Every time we reference length, we have to include the length of the TLV itself, which is stupid. So, this isn't just one. It's 1 plus, sorry, it is whatever the header size is plus the size of the value. So that's 1 plus 8u. This is 4 plus 8u. This is 8. Now I'm keeping those separate so that we can see we're adding 8 bytes every time. Okay. Val.length plus 1u plus 8u. Now it does seem a little bit over the top, I agree, but we're doing it anyway. Oops, u int 32. And then value is raw value.length plus 8u. And we need to u int 32 that again. So I had my lengths wrong for each of the individual types as we were serializing them. That's clearly one bad thing. But it shouldn't matter too much to what we've actually been doing. Okay, so let's just step out of that, and go packet data. Okay, so there's the first 100 bytes, which include the repeating sequence. Now let's deserialize, see what's going on. Seek to 28 bytes, read the packet type. Now the packet type should be a response, which implies that we've got the header lengths correct. Okay, so at this point we should see a valid length being read at this thing here. So reader, we've got our base stream which has a position at 32, non-public members buffer at 32. So we should be starting here, which says it's 41 minus 8, which is 33 bytes. Now let's see what this says. TLV type is a request ID. That's good. That's really good. All right, our meta type is string. And then we go and read the string, which is the request ID. Oh, that's exciting. Okay, so we go to the next one. Read a length type and meta type. We get 30, method, and string. And the string we get out is core TLV. Ah, hang on a minute. Oops. Yeah, okay. Sorry, don't support any of those yet. So what is meta type? None. So let me just make sure I'm not doing anything silly up here. Response.toRaw. So that's all good. It's definitely in this area of deserialization that's breaking, so that's fine. Step out, step in here, parse. Alright, so what I'm going to do now is set a breakpoint here. I'm just going to check the meta type. So we've got a string, and then a raw. It's the oh, yep, so this should be our 4-byte thing. Hey Jay, how you going, buddy? Thanks for coming in. You've missed a fair chunk, mate. We've just we're getting to the end of serializing our packets from abstract data types down into a byte stream. And we're just validating our implementation by debugging, because that's what we do, right? Simple as that. Wow, there's 30 people on stream again. That's fantastic. Okay, so is it a group? No, it's not. We know that it's raw, so that should pull out basically an array of 4. 1, 2, 3, 4, remember? That was our test data, so that's working fine. Next up, what are we doing here? So it says that it hasn't finished. I'm expecting this to barf on the group reading, so let's just see. Meta type uint, and the type is a channel ID, so I'm expecting that to be okay. Yep, the value's what, 40? 10. That's right, 40 was the next one. The next one is a trans group. Oh, that's interesting. Is that the order that we did it in? Not that it matters. It's not the order we did it in, but who cares? So I think this is where we're going to start to see shenanigans. Well, look at this. Yeah, okay. So this could either be that our serialization is wrong, or the deserialization of groups is wrong. So let's find out. So according to this, the length is 44 bytes. Okay. So we'll read that many in, which means we end up with a group reader. And the group reader says that the length is, whoa, that's definitely wrong. Type is definitely wrong. The meta type is definitely wrong. Okay, so as thought, it's the group related bits and pieces that are incorrect. Okay, so when we stumble across a group packet, it should still function exactly the same as any other packet. So let's quickly check to make sure that the to raw functionality of the packet is behaving correctly. So if it's a group, check this out. We haven't specified the right length. uint32 plus 8u. So that's a thing. That's clearly a thing. Let's go back to the deserialization. So according to our group writer, we generate all the TLVs for the thing itself and serialize it, and then we write the length plus 8, then the type, and then the data that we've given it. And that should work just fine, assuming that that this does what we want it to do. So what I'm going to do is I'm going to hit a breakpoint here and watch it serialize quickly. I can take that off to raw. So the length of this thing is 52 bytes. So there's all our group TLV related shenanigans. This is pretty interesting. Just look, oh yeah, so this would be the text related stuff here. So we write the length, we write the type of trans group, and we write 52 bytes worth of data with the length being 60. Okay, so that means now if we go and we go to TLV from binary reader and we go here. Now the length is 52 bytes. That's good. That's exactly what we said it should be. So we read 52 bytes. Oops. Didn't mean to step into that. Okay, let's see where we're at. So the length of the first thing. Oof. Unable to read beyond the end of a stream. Oh, I'm confused. Are you guys? Surely we got more bytes than that. So it's not finished. Uh-huh. You can see what's going on here, right? So the reader is trying to read beyond the end of the stream that it's got behind the scenes. Okay, so it's not finished. But if we look at the reader at this point, we can see that underneath the length is 195 and the position is also 195. Ah, there's our problem. Is that right? Group reader. Ah, hang on. There's our problem. Just here, see it? Group reader. We were still using the reader we were given, and we needed to read out of the group reader. So that's why. This will make a lot more sense now. So this shouldn't buff. The length is 20. The type is trans-URL. The meta type is string. There we go. We're getting the actual URL out now. So that's a good sign. Let's step all the way out. And it didn't buff. So our deserialized packet has 5 elements. Request ID method. It's got all the bits and pieces in it that we had before. It's got one value, which is the group, and inside the group there's another 3 values. Look at that, it's beautiful. It's beautiful. So we should now easily be able to deserialize the request. Sorry, I'm also pull apart the packet data for this request that came in as well, which looks like if we serialize this, sorry, deserialize it, we should end up with the same packet that we had before. There you go, look at that, it's working. Okay, cool. Does that make sense? So we do have the ability to serialize and deserialize. It's a shame Mongo's not here, because that's what he wanted to see as well. We have the ability now to create responses from requests, add TLVs to them, and serialize them, which is cool. And we're already at nearly 10 o'clock. That's flown. If someone wanted to do this in Python, would it be harder than using C#? Well, that's a very tough and religious question. Is it harder as in harder to implement? No. Is it harder to reason about? Yes. Is it easier to bash code out? Possibly, but there's no strong type system that's going to help you, and everything happens at runtime. So I would argue it's harder to write better code in C#. In Python. It's harder to write better Python because it's very hard to reason, and everything's a runtime failure. There's no or very little compile time failure in a Python program. I much prefer C#. Plus, let's not forget that there is already an implementation of this in Python. So there is a Python Meterpreter already, which I'm not using as a reference. I'm trying not to use anything as a reference because I think we should try and make this as C-sharpy as possible. And hopefully from the interface that you can see here, I believe that that's where we're going. We're going very OO because that's what C# is. We're using functional elements along the way. But effectively you can see how we can create a packet object from a data stream, and we can create a response to that packet. We can add elements to that response, and we can serialize that response. And we can deserialize the response again and make sure that the elements are correct. So we currently have a valid way of transforming from packets to data streams and data streams to packets with underlying TLV values and support for nested group TLVs, which is exactly what we want. The only thing that's missing at this point is support for encryption. Any questions? We are 5 minutes short, so I'm going to stop there. We didn't get anywhere near as far as I was thinking, but I still think we kept the pace up. I would very much like to hear what you guys think. Was it too slow? It's good to bash our head against a couple of errors here and there, but because that's what dev is. But I think we achieved something. We achieved something tonight. If there's any questions, quick sing them out before I hit my 2-hour limit and I'll get in trouble. But again, like a previous stream, we bashed out the deserialization, and now we bashed out the serialization. I think we've got both sides of that together, and probably on the next stream we'll put some more testing in and around this, and we'll start mapping things to .NET 4. So hopefully you guys will get a kick out of that as well. So this was stream number 6 already, which is absolutely flown. I'm gonna, given that there's nothing really less to see on screen, come back to my face. Thank you all for attending. It is a Friday night. I know you've probably got something better to do, but there's still like 26 people of you on stream, which is lovely. So bigger font size for what? Just maximize your screen, my friend, because this is pretty big. And you get to a point where like there's so many big words on screen that it's hard to actually see enough and maintain context. So, but yeah, look, I'm really grateful that you guys came along. Stream number 6. Stream number 7 is going to be in 2 days. And that will mean 7 streams in, 12 or 13 days? 12 days. So, yeah, it's been interesting. It's been a fun test, and it's been great having you all come along and experience it with me. And this will, when I get to 7 days, within the 13 or 14, that'll put me hopefully in the affiliate category. So that's awesome. Looking to see how the dispatcher works. Yeah, I've been thinking about that, Brent. The dispatch is going to be interesting, particularly when we abstract the different types of transport. So from here, we're going to step back up a level from TLVs up into sessions. And so we're going to start implementing the Meterpreter server, which has the dispatcher. It has the dispatcher, and it has the transports, and it has the packet handling and the commands and all that sort of stuff. I'm really looking forward to implementing the dispatcher, the channels, the scheduler, and how extensions are going to be used. And this is something that we're going to talk a little bit more about, because I want to know whether you guys think that we should segregate each one of these things, each one of these extensions, into its own app domain. Pros and cons. So have a think about that for the next stream. So anyway, as I said when we started this stream today, be good to your mates. Make sure they're okay. Check in with them every now and then. There's good people out there, and they deserve to be looked after. So thank you for following along, and enjoy your weekends. And hopefully I'll see you on Sunday, maybe Monday. I will keep you posted on the schedule. But as always, I appreciate your support. Have a good one. Till next time. Ciao.